Okay, so Jepsen. First of all, to get started, you've probably heard the quote that if you steal from one author, that's plagiarism. If you steal from many, that's research. I tried to do some research to find out who was responsible for the quote, and it turned out to be too much work, so I decided to just steal the quote.
It's research.
Although I looked at a lot of different resources, I was severely tempted to just plagiarize this guy's. He was a developer at DataStax who used Jepsen to test Cassandra, and then talked about the experience and the bugs that they found afterwards and improvements that he would make to Jepsen. And if you really want to spend a fascinating 45 minutes, I recommend watching his video. Hopefully I'll be able to contribute a little bit independent of what he has. So first of all, what is Jepsen? Some of you have already mentioned Afer, also known as Kyle Kingsbury. He got curious to find out about the promises made by various distributed data stores, and instead of just accepting the marketing at face value, decided to test it. He created a framework for this testing, Jepsen, that's the GitHub repo that we have listed there, and a series of blog posts covering it. So I'm just going to open this up quickly so you can see, or maybe I'm going to open it up. No, doesn't want to open. Okay, well, covered a lot of different databases, etcd, Cassandra, Zookeeper, my personal favorite, Mongo, not because I love Mongo, but because I loved all of the things he discovered about Mongo that he got wrong. Elasticsearch, based on what I learned about Elasticsearch, it made me really question. You know, at the time I was thinking about using it as a possible primary data store because it would be a cool hack. Turns out not a great idea. Over the course of his blog posts, he not only digs into each of these data stores, but he also talks about the theory of distributed data stores and what you're looking for in different types of systems. The CAP theorem, a CP system versus an AP system. Why is linearizability important? And he took the blog posts and turned it into a roadshow. He's done a number of conferences and talks, and then from there turned it into a consulting gig. So if you want to throw a bunch of money at him to help test your data stores or to do other things with Jepsen, he's the one to talk to. Jepsen actually comes from Carly Rae Jepsen. Some of you may remember her song, Call Me Maybe. That was the tagline for his series of blog posts, because some of the data stores may or may not actually end up calling the rest of the cluster with the data they're supposed to. Jepsen tests a lot of different scenarios. I didn't actually realize it tested some of these things until I dug in, like clock drift. Set up multiple nodes, and then find out how sensitive to time is that particular system. Inserting network latency, dropped packets, a complete partitioning of the network, and simulating the crashing of nodes in a cluster in order to find out how well a system was able to survive this. The network stuff is actually done using IP tables, so it is surprisingly easy to adapt if you want to go in and tweak things, because it's just pure IP tables documentation to find out what you can do. What can you test? Well, you can look at collections, add a bunch of stuff to a collection, and then at the end make sure that it's all there. You can have counters. You know, throw data at a system, see if it's actually able to count correctly in order and have the right number at the end. Register basically means a compare and swap register. In other words, write a value, try to write a concurrent value, get it rejected, and even records, like in a more complex data store like Postgres or Cassandra. It's not limited to simple key value stores. So what do you need to set up a Jepsen cluster? You're going to need at least n nodes, where n is generally 6. One of those nodes is going to be a conductor, or basically a control system, and the other 5 are going to be members of your cluster. And the conductor will write data to individual members of the cluster, and then check the status of, and then inject failures into those different nodes. And at the end, it will check to see that they all have correct data. Setting up 6 different systems could be a lot of work. So the good news is, it turns out, you can do simple testing with Docker. Although there are limits to what Docker is going to be able to test. The big thing being clock drift. I'll mention this again later. But basically, your Docker system has one clock. All of the different containers are sharing it. So you're not going to be able to test clock drift very well there. On the other hand, you could set up a bunch of VMs, say in AWS. The DataStax guys actually contributed Vagrant files for being able to set up Jepsen on a system like AWS. And then, of course, finally, you could actually get 6 physical pieces of hardware and network them together. But who does that today in the age of the cloud? Now, if you didn't already know, Jepsen is written in Clojure. There's no escaping it, but it's really not that bad. This is what Clojure looks like. Who here is already familiar with Clojure? Got some maybes. I am not deeply familiar with Clojure, but I've kicked the tires a little bit as part of playing with Jepsen, and it's not your standard C-like language, but you can get over that really quickly if you just let yourself. For those that aren't already familiar, at least a little bit with Lisp, let me just give a quick highlight. First of all, you'll notice the parentheses everywhere. It might look a little bit ugly at first, but it's beautifully simple because it completely disambiguates the parsing. So you know exactly what pieces of information go together. Effectively, this is a parse tree written in text. The first word inside the parentheses is generally going to be a function call, or if you're dealing with objects, like the generator, in this case it's a method call. The rest of the items are going to be arguments. So you'll notice that we are calling cycle, and we are passing to it, in this case you'll notice the square brackets. This is an array. Clojure is designed for running on the JVM, so where a traditional Lisp probably wouldn't bother with having an array data structure. To play nicely with Java, it does have arrays. There you can see a sleep call passing it a 5-second sleep time. These colons are symbols. They're an awful lot like strings, and I don't personally know how a Lisp developer decides when they want to do symbols versus when they want to do strings, but Lisp developers seem to love symbols. In this case, we're creating a dictionary. So type, info, type would be a key, info would be a value, :F would be another key, :start would be the value. So in other words, inside these curly braces, we have a dictionary with 2 keys and 2 values. Sometimes you will see, do we have any examples in here? Looks like we don't. Sometimes you will see a symbol, actually, there we go, right here, as the first word inside of parentheses. In this case, this is actually how you would read out of a dictionary. So more than likely, test contains a dictionary which has :result as one of its keys, which has :valid as one of its keys. And that's how we are reading the results and checking to see that our results were valid. This entire def test definition of a test is a complete test of etcd's functionality. Now, etcd is a pretty simple key value store, so as compared to something like Cassandra, they're not testing as much surface as they could with a more complicated data store. Cassandra would have more def tests present, but they would all have the same basic idea. You're going to give a name for what you're testing, in this case, etcd. You're going to provide an OS. Jepsen handles setup of the nodes that it's controlling, doing things like modifying etc hosts, modifying IP tables, installing any packages that it might need. In order to know what OS it's working with, we tell it here. Out of the box, we have Debian and Smart OS support in Jepsen. But if you decide that you absolutely love CentOS or something else, you could theoretically go in and write your own drivers for setting up a node correctly for working with Jepsen. DB, you'll notice, is calling a function. This is more complicated. Basically, the DB code is responsible for installing the database and potentially resetting the database between each test. So if you wanted to, that could be download a tarball and unpack it, or it could actually be git clone the source code for your database and compile and install it. It's entirely up to you what you want to do inside the DB setup code. Client is what is going to be sending traffic to each of the nodes. Jepsen will provide some instruction to the client, telling it, now I want you to do this type of change. I want you to increment a counter, decrement a counter, whatever. But because obviously Jepsen doesn't come with support for a specific database out of the box, you have to provide one yourself. This could be taking, say, a JDBC driver already available if you wanted to test MySQL and find out how well it does in a clustered scenario. Or in the case of etcd, Kyle was so surprised by the results, he actually wrote his own driver to make sure that it wasn't driver problems that he was seeing in etcd. Model basically keeps track of what should be the state of the data store if it's correct. So in the case of etcd, we write to a key using the client, and at the same time, Jepsen updates the model saying, etcd, if it behaved correctly, should know that the value of this key is whatever. Again, because you know the details of what your data store is supposed to do, you're probably going to have to provide a customization of the model, but Jepsen will at least provide some of the basics to help you design an initial model. A checker will run at the end of the test, and basically what it's going to do, it's going to use the client to find out the state of the DB, and then compare that against what's in the model, and if there are differences, it will report to you what those differences are, and it'll try to figure out exactly when that difference happened so that you can isolate it down to this is the sequence of operations that led to the failure. A nemesis will inject failures into the system. As we mentioned, Jepsen out of the box supports multiple types of failures, clock drift and network partitions. In this case, we're only doing a single type of failure, partitioning the network so that nodes can't talk to each other. Finally, generator is responsible for coming up with a series of operations in some random ordering in order to test the behavior of the system. Although the etcd code has its own custom generator, a lot of this is just reusing primitives already provided by Jepsen. For example, a CAS, an atomic compare and swap operation that should be sent to the system. If you want to learn more about Clojure, AFRA actually also has a series of blog posts with Clojure from the ground up, teaching you what you need to know in order to be able to work with Jepsen code at least, even if you won't be a complete Clojure expert. Obviously, there are plenty of other books available at this point to teach you about Clojure too. So what are some gotchas that you might run into? Testing using a generator throwing random traffic at a system can be slow, especially if you are git cloning, compiling, and installing before you do any other testing. Thankfully, the etcd code was relatively fast. The initial bootstrapping of a test generally takes me about 10 to 15 minutes, depending on my network speed. Although once you've done the initial bootstrapping, you can optimize and just reuse existing nodes and binaries, so that I'm going to demo an etcd run later that gets done in a matter of seconds. Because you're generating random sequences of events, reproducibility can be a problem. In other words, Jepsen will tell you how it managed to generate a failure, but if you decide to run Jepsen again to find out if it fixed the problem, it may not generate the exact same sequence of events. So if you really care about a particular scenario, you should turn that into some type of unit test using another framework in order to guarantee reproducibility. One that I ran into that's really simple, but if you're not familiar with the Clojure ecosystem, could trip you up. Some of the Clojure docs tell you to run line run. It's from, I don't know if I'm actually pronouncing this, LineIngen. It's a tool that they use. For those that are familiar with Ant, it's basically the Clojure equivalent of Ant, automation and installation of packages and so on. Some of the tests are written with an actual main method that gets invoked, but others are just using the def test testing framework, like we saw with etcd. And so even though the docs say run line run, you should actually do line test instead. We mentioned clock drift and Docker being a bit of a problem. There is a trick. Depending on what you are testing, there's a library called libfakeTime that can be used to inject a fake clock into your binary in order to be able to give clock drift to different processes, even if they're on the same host. The problem with libfakeTime is that it really doesn't work well with the JVM. So if you're testing something like Postgres, probably fine. Probably also not worried about it.
Is it LD preload hacks? Is that how it works?
Something like that, yeah.
Probably won't work too well with Go or statically linked libraries then either.
Yeah, that's probably true. I haven't tried that. The most interesting takeaway that I got from digging into Jepsen is I always thought it was limited to data stores. In other words, if I was writing the next clustered database, Jepsen's totally where I would be at. In fact, I'm kind of surprised that the GunDB guys weren't here because they're the ones that were interested in it. They're doing exactly that. But as an application developer, besides curiosity, why do I care? It turns out Jepsen is generic enough that you could actually write a client that is speaking your application API and a model for what your application should do, and then inject failure into a web application or some other type of clustered distributed application. It's not limited to just data stores. And in fact, this is now on my to-do list. I want to create, honestly, the app we have at work, I don't want to tackle that. It'll just make me sad. But I want to write my own little personal app and see how well this works as a real thing, not just as a theoretical possibility. And I guess with that, it's time for a demo. So I mentioned Jepsen comes with Docker already set up. Inside of the Docker directory, you'll notice there's a shell script, up.sh. This is in the background, setting some environment variables, generating an SSH key, and then using Docker Compose to build a Docker image, bring the 6 nodes up, connected to each other, and then, as you'll see, it tells you that you need to execute bash inside of that collection of instances. So right. Looks like maybe it scrolled off the screen. I tested this a couple of times and everything worked fine, but I'll just have to ask you to believe me that that is normally the last line of output telling you exec this command. For those that already know Docker, we're basically just running bash inside of one of the containers. It's actually made a copy of all of the Jepsen code already. So in my case, I'm interested in etcd. And instead of line run, I'm going to do line test.
Stuart, are you using Docker native on your Mac, or are you using the Linux?
I actually am using Docker for Mac. So there you see, it blew away the old etcd cluster, brought up a new etcd cluster. It's throwing a bunch of random reads and writes at it. The Nemesis line there, it just injected a fault. And good news, etcd passed. Full disclosure, when it was first tested with Jepsen, etcd did not pass. In fact, only 2 databases so far have passed on their first try. Zookeeper and, does anybody remember what the second one was? What was it?
SQL Server.
No. And then there's a third that passed on the first try by cheating, kind of. The Foundation DB guys saw Jepsen coming, thought that's great, and did internal testing with it before ever releasing. And then they got bought by Apple. So, a little bit more. Let's look at the contents of this directory. I showed you a single file, which was the heart of the test, but there is a little bit more you need to know about. First of all, you'll notice the project.clj. This is just the Clojure way of defining what your project is. The name of the project, its dependencies, its license, and so on. Anybody speak German? I knew what this name meant. It's actually a pretty creative play on Call Me Maybe in German. It's something like that thing which may or may not be. You will have a source directory, as you might guess. This is in a normal Clojure application where you would find your main method and everything else. When we were looking at the definition of the tests, we saw that it has a DB and a client and so on. This is where we define our code for things like how do you start etcd. And for those that have worked with Debian before, you'll recognize immediately the start, stop, daemon script and a bunch of arguments to it telling it how to get started. And you'll see code for downloading the Go compiler from a tarball, and then in a little bit, git cloning etcd, building it from source, executing it. and so on. So this is actually where the heart, or the majority of your time will probably be spent with Jepsen. It's just scripting those little details like how do you install the stupid software. But once you've got that, Jepsen lets you create a beautiful file like this that's more imports than it is actual code to do the implementation. Neat. And that is what I've got about Jepsen. I can try to answer your questions. If not, we're done. Yep.
We tried testing Dynamo.
DynamoDB, as far as I am aware,
Possible to test it because
well, it's not entirely impossible, but it's a lot harder to inject fault into it. One of the, let's see if this is in this Git clone, one of the things that I was surprised to discover is he actually has tests for Postgres RDS. It doesn't do so much injecting fault, it more just throws a bunch of requests at it and sees if it gives back the expected results. So if you were to try and test Dynamo, that's pretty much the best that you could do. Well, no, actually, if you wanted to get your hands dirty, there are a few interesting things you could do. So with Dynamo, those that aren't familiar, Dynamo is kind of an interesting product from AWS. Instead of spinning up a server, installing some software on it, managing it, or instead of essentially having somebody else do the same thing for you, like RDS, where they spin up a Postgres or MySQL server, and it's just like interacting with a normal server as you tune how much RAM it has. With DynamoDB, instead, you just tell it how many reads per second you want and how many writes per second you want on a per table basis. And then in the background, AWS does magic to make sure that it's able to meet that capacity. One thing that I think might be interesting is using Jepsen to dynamically reconfigure Dynamo. Crank up the reads, crank down the reads, and see at what point there is unexpected behavior. Jepsen would be able to do that. Although, now I'm going to toss in my cynical. If you've had experience with Dynamo,
It's going to fail.
it's going to fail. Yeah.
The architecture for Dynamo lends itself to making shopping carts. And that's about it.
And only shopping carts at scale.
Right.
If you are Amazon scale, you probably have enough continual load to smooth out the noise around capacity. One of the problems we've had is we are not AWS scale, and so it's pretty easy for our users to suddenly throw 3 or 4 times as much traffic as we were expecting. And Dynamo just throws errors if you go over your provisioned reads or writes. It does not give any sort of grace period. It doesn't give any, it immediately hard error code.
So that example that you ran against that speed, is that pretty typical of how long the test runs?
No. Because etcd is a pretty simple key value store, and it was basically just doing a bunch of compare and sets. It was pretty easy to cover the test area on etcd really quickly. Whereas the Cassandra guys, they apparently have test runs on the order of hours to fully regress using Jepsen.
Is the discrepancy more feature-based?
Yeah.
Database performances?
Yep. Well, also, it does actually help that etcd recovers very quickly from partitions, whereas it's not unusual for some distributed systems to take tens of seconds to adjust after a network partition, in which case Jepsen will be slower there just because you can't inject fault as quickly since you have to give the cluster enough time to adapt to each failure. Any other questions? I'm glad I was able to answer all of them.
All right.
Hand it back to JT.
Okay, thank you.